So the whiteboard is out again, so this is going to be another side of maths. So this video is going to be a continuation of the last maths video that I put out, and we'll also continue into a third video which will be released in a couple of weeks. So in my previous maths video, which explained why nano is times 10 to the minus 9 and how to write things in that scientific notation, we came across that 10 to the power minus 9 is equal to 1 over 10 to the 9. So in this video I'm going to explain where that comes from and some of the basis of how you multiply these exponents together. So first thing we have to talk about is some rules of mathematics. So in mathematics, any number, so let's call it x, this is called the base, to a power or an exponent, or sometimes known as an indice, 0 is always going to be equal to 1. That doesn't matter if it's 1 to the power 0, 0 to the power 0, 100 to the power 0 is always equal to 1. Another thing we have to have a rule for is what happens when we multiply exponents together. So let's take x and we put it to the exponent a and we multiply it, I'm using dot to represent multiplication, by x to the exponent b. So for multiplication of exponents, the base, in which case is x, always has to be the same. So this comes out to a rule where you add the exponents together. So if this was x to the 1 times x to the 2, you do x to the power 1 plus 2, which is 3, so it's x to the 3. Similarly, when we divide, so if we do x to the a divided by x to the b, in this case the exponent bracket goes to negative, so you have a minus b. The final one, which we'll come across quite often, is what happens if you have x to an exponent and the whole thing is to the power of something. So let's say we had, again, x to the a, all that's in brackets, and it's all to the power of b, in which case this becomes x a times to the power a times b. So these are your general rules of doing some mathematics of exponents, and in the next video we'll be using this because we'll be looking at what happens when you're trying to find areas of nanostructures, dividing big values of resistance by small values of length. So this is what's going to become useful for that. Also, this is also very useful for GCSE and A-Level maths, and also some university maths as well. So the question is, how does this help us find why this identity is true? So if I had a value of, let's say, x to the a, and I'm going to multiply that by x to the minus a, we can do that, we can sum these together, so we have x to the a minus, because we're adding, but because this is a minus it dominates, so you have a to the a. We can write that as equal to x to the naught, and using that identity we had previously, we can say that that is equal to 1. Therefore we have x to the power a multiplied by x to the minus a is equal to 1. We can rearrange this so we can have x to the minus a is equal to 1 divided by x to the a. And then we have this in this form, so we can just substitute x for 10, we can substitute a for 9, and we end up with this identity, so this is why this comes out as true and comes in useful when doing maths. So hopefully you found that useful, and I look forward to seeing you again in another video.